In this today's video session, we are going to learn Unit 11 Periodic Classification of Elements, and we also discuss about the concepts of classification of elements proposed by various scientists from early to modern period. Come, let's move on to the video session.
Welcome children. Today we are going to learn Unit 11 Periodic Classification of Elements. Let's enter into the lesson. Introduction. All existing matter in our surroundings is made up of basic units known as elements. Initially, in the year 18, only 31 chemical elements were discovered. After some advancement in technology, in the year 1865, about 63 more elements were discovered. This created the need for the periodic classification of elements. Presently, there are 118 elements known to us. Out of these 118 elements, some elements are man-made. They started looking for some pattern in their properties on the basis of which they could study such a large number of elements with ease. Let us discuss the concept of classification of elements proposed by various scientists from early to modern period. In the year 1817, Dobberiner, a German chemist, suggested a method of grouping elements based on their relative atomic masses. And he arranged the elements into groups containing 3 elements each. He called these groups as traits. Why they call these groups as traits means in each group they containing only the 3 elements. So tri means what? 3. In each traits atomic mass of middle elements the same as average of atomic masses of other 2 elements. This statement is called the Dobberiner Law of Traits. Let's see the table of trait groups. Let us see the trait 1. This trait was made up of the alkali metals lithium, sodium and potassium. For example, how to find this? In the trait group 1, arithmetic mean of atomic masses of first and third element is what? Lithium is 6.9 plus potassium is 39.1. When you add this, add and divided by 2, you will get the 23. That is equal to the sodium atomic mass. So that atomic mass of sodium middle element is what? 23. That is the Dobberiner's law. So what is Dobberiner's laws? In each trait's atomic mass of middle elements the same as average of atomic masses of other 2 elements. Next one is trait 2. The halogens chlorine, bromine and iodine constitute one of the traits. Okay, you will do this calculation at home. Chlorine atomic masses is 35.4, bromine is 79.9, iodine is 126.9. So when you add this first chlorine and third one iodine element and divided by 2, you will get the atomic mass of bromine value. Next one is trait 3. This one also do yourself. Calcium atomic mass is 40.1, strontium 87.6, barium 137.3. Limitations of Dobberiner law. Dobberiner could find only 3 traits from the elements known at the time. All the elements could not be classified in the form of traits. Hence, this system of classification was not found to be useful. So, Other method of classifying elements were developed, that is Newlands Law of Octaves. In 1866, John Newlands arranged known elements in the increasing order of their atomic mass. This law states that every eighth element in the order of increasing atomic mass has properties similar to the first element. Have anybody played piano? John Newlands arranged the elements based on octaves, that 8 notes. The octave of Indian music system is Sari, Kama, Pada, Nisa. The first and last notes of this octave are same. Example, Sa. Likewise, in the Newlands table of octaves, the element F is 8 from the element H, thus they have similar properties. So, John Newlands arranged all the elements based on the 8 notes octaves. So, every 8 elements in the order of increasing atomic mass has properties similar to the first element. Limitations of Newlands octaves. Two elements being fitted into the same slot, example cobalt and nickel. Next one, dissimilar properties of elements were fitted into the same groups, example cobalt, nickel. And third one, valid only till calcium. That is, the law of octave was not valid for elements that had atomic masses higher than that of calcium. And next one is discovery of noble gases. Discovery of inert gases neon argon at later stage made the ninth element similar to the first one. Example, neon between fluorine and sodium. Mendeleev's periodic table. In 1869, a Russian chemist and teacher published a table of elements. Mendeleev arranged the elements in the periodic table in order of increasing atomic mass. He arranged 56 elements known at that time according to his law of periodicity. This was best known as the short form of periodic table. Let's see the features of Mendeleev's periodic table. It has 8 vertical columns called groups and 7 horizontal rows called period. Each group has 2 subgroups A and B. The elements have similar properties were placed in the same group, but certain elements could not placed in their proper groups in the manner. The reason for this wrongly determined atomic masses. Those wrong atomic masses were corrected. Example, the atomic mass of beryllium was known to be 14. Mendeleev reassessed it as 9 and assigned beryllium a proper place. And some columns were left vacant for elements which were not known at that time, and their properties also were predicted. This gave motivation to experiment in chemistry. And after that, Mendeleev gave names for those vacant place called Eka aluminum and Eka silicon to those elements which were to be placed below aluminium and silicon respectively in the periodic table. After that, he discovered germanium later during his lifetime. So, this proved him correct. Limitations of Mendeleev. Elements with large difference in properties were included in the same group. Example, hard metals like copper and silver were included along with soft metals like sodium, and potassium. We can able to see in the table metals like copper and silver, these are odd metals, were arranged in the same place soft metal sodium potassium. No proper position could be given to the element hydrogen. Non-metallic hydrogen was placed along with metals like lithium, sodium and potassium. We can able to see in the table non-metal hydrogen is placed along with the metals like lithium, sodium and potassium. The increasing order of atomic mass was not strictly followed throughout. For example, cobalt, nickel, tellurium and iodine, they all elements placed somewhere else. So this mentally periodic table also not satisfied because of not arranged all the elements in proper position. So they brought modern periodic table. In 1913, the English physicist Henry Moseley through his X-ray diffraction experiments proved that properties of elements depend on the atomic number and not on the atomic mass. So, the modern periodic table was prepared by arranging elements in the increasing order of their atomic number. So, this modern periodic table is the extension of the original Mendeleev's periodic table and known as the long form of periodic table. Features of modern periodic table. All the elements are arranged in the increasing order of their atomic number. The horizontal rows are called periods. There are 7 periods in the periodic table. Vertical columns in the periodic table starting from top to bottom are called groups. There are 18 groups in the periodic table. Based on the physical and chemical properties of elements, they are grouped into various families. Are groups in the modern periodic table. Group 1 alkali metals, Group 2 alkaline earth metals, Group 3 to 12 transition metals, Group 13 boron family, Group 14 carbon family, Group 15 nitrogen family, Group 16 oxygen family, Group 17 halogens and Group 18 is noble gases. We will see briefly about all these groups and families. Dear children, do you know what is IUPAC? The International Union of Pure and Applied Chemistry is an international federation of organizations that represent chemists from various countries. IUPAC is registered in Zurich, Switzerland, and the IUPAC Secretariat is an United States. New elements in the periodic table named by IUPAC having atomic number 113 to 118 have been named by IUPAC. Now we'll see the classification of elements into blocks. In the long form of periodic table, the elements are arranged in the order of their atomic numbers. Atomic number of an element is equal to the number of protons inside the nucleus of its atom. There are in all 18 vertical columns and 18 groups in the long form of periodic table. These groups are numbered from 1 to 18 starting from left. There are 7 horizontal rows called periods in the long form periodic table. The elements of groups 1, 2 and 13 to 17 are called the main group elements. These are also called normal elements. The elements of groups 3 to 12 are called transition element. Element with atomic number 57 to 71, that is lanthanum to lutetium, occurring after lanthanum, are called lanthan acid. Element with atomic number 89 to 103, actinium to lawrencium, are called actinides. These elements are called F block elements and also called inner transition elements. Dear students, we already know that shells, K shell, L shell, M shell, N shells. These subshells are designated as S, P, D and F. Based on the arrangement of electrons in subshells, the elements of periodic table are classified into four blocks, namely S, P, D and F blocks. Let's see all these block elements. Let's see S block elements. It includes group 1 alkali metals and group 2 alkaline earth metals elements. They are also called as representative elements. First element in the group 1 is hydrogen. Next is second one is lithium. Third one is sodium. Fourth one potassium. Fifth one rubidium. Sixth one cesium. Seventh one francium. And in the second group, beryllium, magnesium, calcium, strontium, barium and radium. The elements of group 1 except hydrogen are metals. They react with water to form solutions that change the color of a vegetable dye from red to blue. These solutions are said to be highly alkaline or basic. Hence, they are called alkali metals. For example, red cabbage is turned into blue, is called anthocyanins. The elements of group 2 are also metals. They combine with oxygen to form oxides, formerly called earths, and these oxides produce alkaline solutions when they are dissolved in water. Hence, these elements are called alkaline earth metals. Beryllium does not react with water and magnesium reacts only with steam, but the other react readily with water. Next one is P block elements. P block starts from the 13th group and goes till 18th in the periodic table. They include boron, carbon, nitrogen, oxygen, fluorine families in addition to noble gases except helium. This black block contains all three types of elements: metals, non-metals and metalloids. Elements presented in the P blocks are helium, boron, carbon, nitrogen, oxygen, fluorine, neon, aluminium, silicon, phosphorus, sulfur, chlorine, argon, gallium, germanium, arsenic, selenium, bromine, krypton, indium, tin, antimony, tellurium, iodine, xenon, thallium, lead, bismuth, polonium, astatine, radon, neonium, fleurium, moscovium, livermorium, tennessee, organson. Do you know coal is used in villages to cook food? It is nothing but a P block element. Example, carbon. Diamonds are used for making beautiful ornaments are also made up of carbon. Aluminium foil made up of aluminium is also made up of P block element. Next, D block elements. It includes group 3 to 12 elements. They are found in the center of the periodic table. Their properties are intermediate to that of S block and P block elements and so they are called transition elements. Now we'll read the D blocks of elements in the periodic table. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium, Aphanium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold, mercury, rutherfordium, dubnium, seaborgium, borium, osmium, meitnerium, drumstadium, genium, copernicium. Next, F block elements. It includes 14 elements after lanthanum, La57, called lanthanides, and 14 elements after actinium, Ac89, called acetonides. They are placed at the bottom of the periodic table. They are also called as inner transition elements. These F block elements already mentioned in the D blocks in the third group, 6th period and 7th period. Let's see the advantages of the modern periodic table. The table is based on a more fundamental property, example atomic number. It is easy to remember and reproduce. The table completely separates metals from non-metals. Each group is an independent group and ideas of subgroup has been discarded. Position of 8 groups in Mendeleev table is also justified in this table. Now let's see the position of hydrogen in the periodic table. Hydrogen is the lightest, smallest and first element of the periodic table. Its electronic configuration is 1s1, is the simplest of all the elements. It occupies a unique position in the periodic table. This hydrogen behaves like alkali metals as well as halogens in these properties. In the periodic table, the hydrogen is placed at the top of the alkali metals. Hydrogen can lose its only electron to form a hydrogen ion like alkali metals. It can also gain one electron to form the hydride ion like halogens. Alkali metals are solids while hydrogen is a gas. Hence, the position of hydrogen in the modern periodic table is still under debates as the properties of hydrogen are unique. Dear children, do you know hydrogen is the most abundant element in the universe and makes up 4/5 of all ordinary matter? It is believed to be the fuel of the future, but it remains difficult to produce, transport, and store. At extreme temperatures and pressures, like those at the core of a gas giant planet, hydrogen can become metallic. A gas giant is a large planet composed mostly of gases such as hydrogen and helium with a relatively small rocky core. The gas giant of our solar system are Jupiter, Saturn, Uranus, and Neptune. Position of rare gases. The elements helium, neon, argon, krypton, xenon, and radon of group 18 in the periodic table are called as noble gases or rare gases. They are monoatomic gases and do not react with other substances easily due to completely filled subshells. Hence, they are called as inert gases. These gases are found in very small quantities, so hence they are called as rare gases. Metals are typically hard, shiny, malleable. This can be made as sheet, fusel, and ductile. Ductile means can be drawn into wire. These metals with good electrical and thermal conductivity. Except mercury, most of the metals are solids at room temperature. Metals occupy larger area in the periodic table and are categorized as alkali metals, example sodium and potassium. These metals are presented from lithium to francium top to bottom. Next is alkaline earth metals, example calcium and magnesium. These metals are presented from beryllium to radium top to bottom. Next is transition metals, example iron and nickel. These metals are group 3b to 2a. Next is other metals, example aluminum and tin, p block metals. Next is nonmetals. A nonmetal is an element that does not have the characteristics like hardness, shiny, malleable, shootable, and ductile. In other words, a nonmetal is an element that does not have the properties of metal. Example, all nonmetals are arranged in p block only. P block nonmetals carbon, nitrogen, oxygen, phosphorus, sulfur, selenium, halogen, fluorine, chlorine, bromine, and iodine. What is metalloids? Elements which have the properties of both metals and non-metals are called as metalloids. Example, boron, arsenic. What is alloys? During 3500 BCE, people used an alloy named bronze. The idea of making an alloy was quite old. The majority of the metallic substance used today are alloys. Alloys are the mixture of two or more metals or formed by mixing molten metals thoroughly. Rarely, non-metals are also mixed with metals to produce alloys. For example, the alloy brass is made from copper and zinc. Advantages of alloys. Alloys do not get corroded or get corroded to very less extent. They are harder and stronger than pure metals. Example, gold is mixed with copper and it is harder than pure gold. They have less conductance than pure metals. Example, copper is good conductor of heat and electricity, whereas brass and bronze are not good conductors. Some alloys have lower melting point than pure metals. Example, solder is an alloy of lead and tin which has lower melting point than each of the metals. Do you know monal is an alloy of nickel, 67% and copper with small amounts of iron, manganese, carbon and silicon. It is stronger than pure nickel and it is extremely resistant to corrosion even that caused by seawater. It is used in aircraft construction and skins of experimental rocket plants. Thank you.